Ever wondered if we are alone in the universe, or if there are advanced civilizations out there waiting to be discovered? This question, as timeless as humanity's gaze towards the stars, has fascinated both scientists and laypeople alike. It's a question that pushes boundaries, inviting us to broaden our understanding of life itself and our place within the cosmos. Some argue that the universe, teeming with billions of galaxies, each filled with billions of stars, surely must host other forms of life. Others, however, propose that life as we know it might be a rare, perhaps unique, cosmic accident. This debate is not just a philosophical musing. It holds profound implications for science, society, and even our self-perception. But how do we navigate this cosmic conundrum? How do we decipher the silence of the universe? Stay tuned as we dive into the intriguing debate about alien existence. Many scientists and enthusiasts believe in the existence of extraterrestrial life. Here's why. First, consider the sheer scale of the universe. It's so vast, it almost defies comprehension. We're talking about billions upon billions of galaxies, each teeming with millions to billions of stars. And around these stars, it's likely there are just as many planets, if not more. With such astronomical numbers, the odds seem to favor the existence of life somewhere out there. Secondly, let's talk about the Goldilocks zone, also known as the habitable zone. This is the just right range around a star where conditions might be suitable for life as we know it. Not too hot, not too cold, but just right for liquid water to exist. And where there's water, there might be life. We've already identified numerous exoplanets that reside in their star's habitable zone, further increasing the likelihood of finding extraterrestrial life. Thirdly, there's the Drake equation. Developed by astronomer Frank Drake in the early 60s, this equation is a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. While the variables in this equation are filled with uncertainties, even the most conservative estimates suggest that we are not alone. But it's not just about numbers and probabilities. It's also about the resilience and adaptability of life itself. Life on Earth has proven to be incredibly tenacious, thriving in extreme conditions from deep sea vents to frigid Antarctic lakes. If life can persist here against all odds, who's to say it can't on other worlds? These compelling points make a strong case for the existence of aliens, yet others remain skeptical. The universe is a vast, complex place, and our understanding of it is still evolving. But one thing is certain: the question of alien existence continues to captivate us, driving us to explore, to seek, to understand. Because in the search for extraterrestrial life, we are also searching for answers about ourselves. On the flip side, there are those who argue against the existence of aliens. Let's explore their reasoning. One of the strongest arguments against the existence of extraterrestrial life is the lack of tangible evidence. Despite decades of searching, we haven't found definitive proof of life beyond Earth. No little green men, no alien artifacts, no radio signals from a distant civilization. Nothing. This absence of evidence for some equates to evidence of absence. But it's not just about the lack of physical proof. There's also the Fermi paradox to consider. Named after physicist Enrico Fermi, this paradox asks a simple question. If the universe is teeming with life, where is everybody? Why haven't we been contacted yet? Why haven't we seen signs of advanced civilizations? The silence of the cosmos is deafening, and for some, it's a clear indication that we're alone. Then there's the Great Filter Theory. This hypothesis suggests that life in the universe faces a series of challenges or filters that it must overcome to become a spacefaring civilization. These might include things like developing complex life, surviving self-destruction, or learning to harness the energy of stars. The Great Filter Theory posits that if we haven't found aliens, it's because they've failed to pass these filters. Now, it's important to note that these arguments aren't definitive. They're based on our current understanding of the universe, which is continually evolving. they're also based on assumptions that aliens would want to contact us, that they would leave evidence we could find, that they would exist in a way we can comprehend. These opposing viewpoints add complexity to our quest to understand our place in the universe. In the end, whether or not we're alone is a question that may remain unanswered, but it's a question that pushes us to explore, to learn, and to grow. And maybe, just maybe, that's the point. While the debate continues, one thing is clear: the need for serious, unbiased investigations. The quest for extraterrestrial life is complex, requiring a significant investment of resources. But it's not just about pouring time and money into these explorations. It's about adopting a diverse approach, one that doesn't shy away from the unfamiliar, but rather embraces it. Because in this vast cosmos of ours, who's to say what form life could take? However, we must exercise caution. We can't chase every shadow or jump at every claim. There's a fine line between curiosity and credulity, and we must tread it wisely. Our investigations, while open-minded, must be grounded in the scientific method, upheld by rigorous testing and evidence. We should be like detectives, not just believers, sifting through the claims, looking for the ones that hold water, the ones that make us pause and think. In our pursuit of knowledge, we must remain open yet critical, always seeking truth amidst the extraordinary. Whether or not aliens exist, the quest for understanding our universe continues to inspire scientists and dreamers alike. Until we have definitive answers, we can only continue to explore, to question, and to wonder.